This is Algebra 3, Test 7 review. What this is covering, lessons 1 through 32, something like that, or 30. Anyway, we're going to start off here with your review, which you guys have in hand, with question number 6, after they've been ordered from most needed. On down, question number 6 says 15 years ago, Phil was twice as old as Daryl was then. 3 years from now, Daryl will be as old as Phil was 4 years ago. How old is Phil now? Okay, so I'm going to kind of count on the fact that, let's see, let me do this. I'm going to go ahead and pull up our answer key, scoot it over to the other side so I can see what our answer should be. All right, 15 years ago. All right, so Phil minus 15, right? Phil minus 15. Was twice as old, okay, was twice as old as Daryl was then. Daryl minus 15. Okay, so Daryl minus 15 times 2 is going to be equal to Phil minus 15. Okay? All right. 3 years from now, Daryl will be as old as Phil was 4 years ago. All right, so 3 years from now, Daryl plus 3, okay, as old as will be equal to Phil 4 years ago. Okay, Phil minus 4. How old is Phil now? Okay, so we want to solve for P. Okay, does that make sense? Okay, so what we can do probably with this second equation is we want to solve for D in terms of P, so I'm going to subtract 3 here and subtract 3 here. That's going to allow me to get Daryl equals Phil minus 7. Does that make sense? All right, now you have a couple possibilities there. Somebody in here might want to solve this using a matrix. In both equations, I would have to get D and P on the same side of the equal sign in the same order. Does that make sense? But I'm going to solve this in kind of a standard way. So here, I'm going to substitute in P minus 7 for where I see D in the first equation. Now, in the first equation, this being number 1 and this being number 2, right, equation number 3 is going to be P minus 15 equals 2 times P minus 7 minus 15. Does that make sense? Okay, P minus 7, because that's what I'm subbing in for my D. I got P minus 15. All right, we'd go ahead and, okay, finish out what's inside the parentheses. What would that be, minus 22? Minus 22. Distribute the 2. We got P minus 15, or Phil minus 15 is 2P minus 44. Okay. See, let's go ahead and let's add 44 to both sides. And let's subtract P from both sides. That's going to leave me with just a single P, or Phil. If saying P over and over again doesn't distract you. Okay, so negative 15 plus 44, or 44 minus 15, what's that coming out to? Is that something like 39 or 29? 29. So 29 equals P. P equals 29. That's our answer. Okay, does that make sense, or would you rather see it done using a matrix and how to set up those two equations? Do we get this? Okay. All right, let's see. Next question was number 16. Number 16 shows me 64x cubed, y to the 6th, minus 27, z to the 9th, w cubed, and it wants me to factor this. What I'm looking at here is this is the difference of two cubes. Do we remember the difference of two cubes a little bit? The form that I'm trying to get this into is f minus s times f squared plus fs plus s squared. That'll be the form of the final answer. But the very first thing I have to do is divide or do the cube root of everything. All right, what's the cube root of 64? No, the cube root, not the square root, should be 4, right? All right, what's the cube root of x cubed? X, what's the cube root of y to the 6th? y squared, all right? Because where it deals with the exponents there, I'm dividing by 3, right? The cube, all right? All right, the next part here, okay, what's the cube root of 27? 3, good. All right, so I got 3. The cube root of z to the 9th is z cubed, and the cube root of w cubed is w. That is my f minus s, right? I've got the first part here, okay? Does this make sense? The next part is I need to identify f. Well, f is 4xy squared, okay? And I want to square that, so I'm going to square each individual part there. 4 squared is 16. X squared is x squared, and y squared squared is what? Nope, y to the 4th. Because y squared squared, that's y squared squared. I multiply those exponents. Okay? Does that make sense? Okay? All right, so 16x squared y to the 4th plus, always plus. I know that you're looking and you see that that's a negative 3, but keep in mind, if I took that whole thing, I would get negative 3 cubed, right? Well, negative 3 times negative 3 is positive 9. Okay? Z cubed squared. Z to the 6th, right? Z to the 6th. W squared, right? All right, now this next part is just S. Oh, I'm sorry, I messed up. I messed way up. Sorry about that. Because we're taking F times S, so 4 times 3. 4 times 3. I was skipping to the last step. It's not negative, though, because S is not referring to the negative. It's referring just to the 3z cubed W. So I'm getting 4 times 3 is 4 times 3 is 12. Right, and because none of those variables are the same, I just bring them, all over. So typically I keep them in alphabetical order. So W, X, Y, Z. So we'd get W, X, Y squared, Z cubed. Now sometimes they don't like that, just because the other way that we would order this is Z cubed, Y squared, WX. Right? They want those larger exponents first. I'm not really concerned about that. I'm not going to count it wrong, just as long as you have everything there and everything has the right exponent. All right, finally, what would have been what I should have had earlier is 9 z to the 6th w squared. And then, okay, if I can get all that in there. All right, that's my answer. Do we understand this better than we have before? Okay. All right. After that, number 18. Number 18, let's see, simplify. We have y b plus 2 times the square root of x to the 6th to the 2b over x 3b minus 1. I'm going to make sure I've got that pulled up. We're going to want everything in the numerator position. All right, so let's handle our numerator first. I'm going to go ahead and simplify the square root of x to the 6th, right? So first thing, I'm dealing with that. The square root of x to the 6th is x cubed, right? Because that's 6 divided by 2, because there's a 2 there. All right, so I get x cubed to the 2b, right? What do I do with those exponents? Multiply or add? Multiply. So I get x to the 6b, okay? So what I'm left with is I have y to the b plus 2 times x to the 6b, okay? So that's dealing with the numerator all over x to the 3b minus 1. And because I want everything in the numerator position, I'm going to bring this guy up here. Okay, so step 2, I'll pick a different color here. Y to the 3b plus 2 really shouldn't, let's see, y to the b plus 2 shouldn't change, right? There's no other y's to affect it, right? But then I've got x to the 6b, okay? And I have x to the, what happens to the 3b minus 1 as I bring it up? Become negative 3b plus 1, okay? Now, there's multiplication through here, so what happens to the exponents of the x's? Add them. So, you know, if I'm looking at step 3 here, I got y to the b plus 2, x, so I've got 6b minus 3b. What am I left with? 3b. Is there anything to affect the plus 1? No. So double checking over here, x to the 3b plus 1, yb plus 2. It's got it in a different order in the answer key, but it's the same answer because multiplication is commutative. Okay. All right. Do we understand that? We understood all the individual steps to get there? Okay. All right. Number 20, last of these 7s. Number 20, the airplane traveled at m kilometers per minute. So I'm going to start off with distance equals rate times time. Rate equals distance over time. Time equals distance over rate. D equals R equals T equals. I always start these questions off just like this before I've written anything down so I know what I'm working with and where I'm at. All right, the airplane traveled m kilometers per minute. Kilometers per minute, is that a distance, is that a rate, or is that a time? Kilometers per minute. Rate, okay? Rate. You don't live 45 miles per hour away. Does that make sense? All right, so m kilometers per minute is my rate. M goes there. Okay, knowing where things go is important. For d kilometers, that should be easy, right? Distance, right? And was 7 minutes late. All right, at this point, the last thing is going to be based upon one of these three ratios up here. So t is distance over rate. All right, so in this case, time is d over m, and I was 7 minutes late, which means I was plus 7. So do we understand the plus 7 there? Okay. Now, typically these questions go, how fast should we have traveled to get there on time? Speed is a measurement of distance, rate, or time. What is it? I have to solve either for a new distance, a new rate, or a new time. If I want to know how fast I need to go, new rate. Okay, new rate. All right. Are we changing the distance at all? Are they changing the distance? So what should go on top? D. And I'm going to go ahead and do this for us. I'm going to go ahead and put D over 1. Okay, still D. Rate is distance over time. So I'm going to come back down here, okay, to find the time that I have. Well, my time was originally D over M plus 7, but I want to get there on time, so do I still want plus 7? How do I undo that 7? Minus 7, okay? But that's going to give me a fraction minus a number. I want to go ahead and simplify that, so I'm going to go ahead and put that over 1. What is my common denominator there? M. So I'm going to multiply by M over M. All right, so that's giving me D over 1 over D minus 7M all over M. I have a fraction. I'm dividing by a fraction. What do I need to do instead? Multiply by the reciprocal. So I'm going to multiply D times M. I'm going to multiply 1 times D minus 7M. That's going to give me dm over D minus 7M. And because this was in kilometers per hour, km per hour, let's double check here. This was question number 20. dm over D minus 7M was our answer. Do we understand how to solve this type of question now? Yes? No? Okay. All right. All right. Okay, got it? All right, perfect. All right, this moves us into the 6s with 5 and 13. 5. Let's see, we have f of x equals x squared plus x. And we want to find f of x plus h. F of x plus h. Now, if they said find f of 3, we would have gone in here, we would have got 3 squared plus 3, right? All right, we're just going to take this and plug it in for the x values. So what I'm doing in f of x plus h is rewriting this as parentheses, parentheses, plus parentheses, parentheses. But instead of 3 going inside those parentheses, I'm writing x plus h and x plus h. Does that make more sense? Okay. Now, with something like x plus h squared, that doesn't mean x squared plus h squared. That actually means x plus h times x plus h, which is FOIL, right? X plus h times x plus h plus x plus h. All right, so FOILing here, I get x squared plus xh plus xh plus h squared plus x plus h, right? Do we understand all that? All right, I have got x squared. I have two xh's, so 2xh plus h squared plus x plus h. Let's see, this was question number 5. X squared plus 2xh plus h squared plus x plus h. That's my answer. What's that? You feel down? Okay. Do we got this now? Great. Okay. Let's see. 13. While occupying new territory in northern Gaul, the Roman militia found that it took 12 men, 3 acres, 4 hours. Scout. All right, so this is rate times workers times time equals jobs. All right, we never know the rate to start with. We do know the number of workers. It took 12 men. It took them 4 hours to do 3 acres. All right, that's going to help get my rate. So it's going to get rate times what? 48 equals 3. All right, so rate is going to equal 3/48. Will that reduce? Probably 48. What do I get? 1 over 16. So rate equals 1 over 16. So I'm going to hold on to that 1/16th because that's one guy, you know, that's his rate. 1 acre every 16 hours is what one guy can do. Does that make sense? All right. So this is the second part to it. The first part is solve for r. The second part is solve for time. Okay, with the rate that we found. Now we added 12 more guys to do the jobs, right? So how many guys am I working with now? 24. So keep in mind, it won't always be the same number of guys. We're going to solve for time. We want to know how long it's going to take them to do 18 acres. All right. So first thing we're going to do, 24 times 1 divided by 16. 3 over 2, is that what you said? All right, so that's giving me 3 over 2t equals 18 over 1. Because, can I divide by 3 halves? No, but I can multiply by 2/3. All right, so t should equal 36 divided by 3, right, or 12 hours. All right, that was what, question number 13? 13. All right, got it. We feel better about that? Okay, it will be the same process every time. Solve for rate, plug in new numbers, solve for time. All right, that was 13. Now we're going down to the 5s with number 2. Hopefully we're paying close attention here. Find the domain of the function. We have f of x equals, we've got square root of x plus 5, and we have x squared plus x minus 6. Now, we always want to do the numerator first, and the number 1 rule here is that in here, I cannot have x has to be greater than or equal to 0. The reason why is because I am not allowed to have a negative number in my radical and still get a real number for my domain. Does that make sense? Okay. Rule number 2 is that my denominator cannot be equal to 0. Okay, so if I'm looking down here, x cannot equal 0. So I'm going to have to solve for the zeros to find out what is left out, excluded values. Does that make sense? All right, so the first part up here, x plus 5, because I know that whatever goes in there has to be greater than or equal to 0, I can say x plus 5 is greater than or equal to 0. Subtract 5, x is greater than or equal to negative 5. Does that make sense? All right. So I know that my domain has to be greater than or equal to 5, and then I use this part down here, x squared plus x minus 6. And I factor down here to use the zero product property to find the zeros. I'm going to get x and x. Because there's a negative there, I have to have plus and minus. I know that my plus is going to be 1 bigger, or be at least, yeah, it's got to be 1 bigger, so I should get a 3 and a 2, right? So what x cannot equal, it cannot equal negative 3, and it can't equal 2. So important here, are either of these numbers or both of these numbers greater than negative 5? They're both. All right, so my answer here is that x is a set of all real values such that x is greater than or equal to negative 5, and x cannot equal negative 3 or 2. That's my answer. Now, if my answer here had, let's say they were less than negative 5, I wouldn't have had to include them, because the first rule is priority over the second. Okay? Could you use that? You can use it for, you can use the quadratic formula for the denominator. Yes. Yep. Question was, could you use the quadratic formula to solve the denominator? And the answer is yes, the same way that we just did. Let's see, number 8. Solve for L. Okay, I probably am not going to get all the way through this one. How many have we done? 1, 2, 3, 4, 5, 6, 7. Done 7 of them. All right, I'll try to, we're trying to solve for L. Okay, keep that in mind. We have 3s equals, change that, 3 over 2t. We have 8d over L minus 3m over d. All right, so first thing I'm going to work with is inside the parentheses. I've got two fractions I'm trying to subtract. I need a common denominator. The common denominator is dl. Okay, so I bring down, I got 3s equals 3 over 2 squared minus 3ml all over dl. Now, the next thing I have to work with is my multiplication. So I have 3s, and I'm going to multiply the numerator times the numerator, which is going to mean distributing. 8 times 3 is 24. D squared minus 9ml. And then on the bottom, I'm going to get 2TDL. Does that make sense? Now, I want to get everything in a numerator position, so I'm going to multiply both sides by 2TDL times 2TDL. Okay? That's going to give me, on the left-hand side, 6TDLS. Right? Really long deal there. Equals 24 D squared minus 9ml. All right, let's keep going here. And because I want to solve for L, I'm trying to get all the L's together. That means I'm going to add 9ml to the other side because it also has an L. So I have 9ml plus 6TDLS equals 24D squared. Now what I want to do is I want to factor out the L. Okay? I'm going to pull an L out of here, an L out of here. Okay, that's going to leave me with 9m plus 6 TDS equals 24D squared. Now this is a lot of steps, but it's really not terribly complicated. Okay, after that, because I want just L, I'm going to divide. So I'm going to get 24D squared divided by 9m plus 6 TDS. I'm going to look at, see if there's anything I can factor out of all of that. And I should be able to factor a 3 out of it, leaving me with 8D squared over 3m plus 2 TDS. And let's see, what question number was this? 8. Let me check that answer. That is correct. Okay, that gets it to me. So, all right, so that was 8. Next one on the list, I'll just go till the bell rings, is 9. 9. We got square root of negative 16 plus square root of 9, square root of negative 9, square root of negative 9, minus square root of negative 5, square root of 5. I'm going to hit pause on this. Whenever I come back from lunch, I'll try to finish as much of the video as I can. All right, I'm back. It's an empty room. Let's see what I can do with this. All right, so we want to go through here. We're going to take all of the negatives, pull them out as i's. So I'm just going to show this as expanded as possible. So we've got I radical 16 plus radical 9. We got I radical 9, I radical 9, minus I radical 5, radical 5. All right, now square root of 16 is 4. Write that off as 4i. Okay? All of these radical 9s can be written as 3's. Okay, so we got 3i, 3i, 3. Okay? And then radical 5 times radical 5 is 5, so we get 5i there. All right, now we got 4i plus we have, let's see, all of this in here. So I'm getting 3 times 3 times 3, which is 27i squared minus 5i. 27, or that becomes plus 27 times negative 1 minus 5i. Okay, we got 4i, then minus 27 minus 5i. Combine like terms, we get negative 27 minus I is what it looks like to me. 4i minus 5i should be minus I. Question number 9 did not come out at all like that. Give me a second. All right, I see what I missed is that what we have in a numerator position on number 9, we are going to go ahead and pull this down, and we're going to grab our numerator, give ourselves a little bit more space here. Our numerator, so we got 27 minus I up top. Our numerator was 2 minus 3i cubed. All right, well, that'd give me negative 27 minus I. We'll go ahead and get 2 minus 3i. Okay, negative 27 minus I over 2 minus 3 times negative 1 times I. Pulling it down again. Okay, negative 27 minus I becomes 2 plus 3i. Now we're not done yet. A lot of people will stop here if they can. We're not done. Because actually what we want to do is we want to multiply by the conjugate of 2 plus 3i. That's going to give me 2 minus 3i. 2 minus 3i, which means we are going to end up foiling. So negative 27 times 2 is negative 54. Negative 27 times negative 3. Okay, this is where I'm going to grab a calculator for this. Negative 27 times negative 3 comes out as positive 81i, positive 81i. Right, then we've got negative I times 2, which would be negative 2i. And then we have negative I times negative 3i. So there, treat that like a 1, negative 1 times negative 3. It's positive 3i squared. Okay, and we can pull that down. Scroll up a little bit here. Okay, so that as we're looking at this, we can go ahead and combine some like terms. And we can make, let's see, we got negative 54 plus 81i minus 2i, and that's going to be negative 3 because that I squared becomes negative 1. So we've got negative 54 minus 3 is negative 57, and then we have positive, we would get 79i. So that's how the numerator breaks down. In the denominator, we've got 2 times 2 is 4, and this is a sum difference, so 3i times negative 3i would be negative 9i squared. All right, well, that is going to be the same as 4 plus 9, okay, because that I squared is a negative 1. 4 plus 9 is 13. You could leave it like that, or you could write negative 57 over 13 plus 79i over 13. Either one, I believe, is correct. If I look at it, negative 57 over 13 plus 79 over 13i. So as I scroll back up through here, you can see if I expand it and I do all this, it's really several steps of different things that take place with those i's. So you want to be careful with this question. Okay, that was question number 9. Okay. Okay, after question number 9, you guys wanted to see question number 11. 11, Machiavelli can mow the lawn in 30 minutes. Okay, so he can mow 1 lawn in 30 minutes. That's his rate. Okay, Carl can mow the lawn in 20 minutes. He can mow 1 lawn in 20 minutes. Machiavelli works for 10 minutes before Carl begins to help. So that would be t plus 10. Okay, let me spread this out a little bit here. Plus 1 over 20 t. How long do they work together to complete the job? 1 job. Okay, so we'll distribute the t plus 10. That's going to give me, let's see, that'll give me 10 over 30. Let's see, plus, I want to look at that, t plus 10, so you're going to get, yeah, okay, we got our 1 over 20t, and our 10 over 30t. Okay, equals 1. Look at number 11. Okay, we should be getting 8. Hopefully I'm going to do this right. All right. So we've got these things. They need to be combined. Okay. 10 over 30t plus 1 over 20t. Okay, let's see. I feel like I'm doing something wrong here. Give me a second. All right, I see what I've done. Okay. And I knew where it was. I just wasn't sure, and it's right here. We should get t over 30 plus 10 over 30 plus what you could call as t over 20. Okay, equals 1. Okay, this comes down as 1/3. You know, we've got t over 30 plus 1/3 plus t over 20 equals 1. So we could subtract 1/3 from both sides. Okay, so I've got t over 30 plus t over 20 equals 2/3, right? That's pretty easy enough to do in your head. 1 minus 1/3 is 2/3 left. All right, here we do still need a common denominator. So I'm going to multiply this by 2 over 2, 3 over 3. And that should give me 2t plus 3t over 60 equals 2/3. Okay. That give me 5t over 60 equals 2/3. You can cross multiply and divide here. Let's see, we would call that 15t equals 120 divided by 15. Let's see. We should get, with 120 divided by 15, hopefully, t does equal 8 hours. Okay. All right. That was, I believe, number 11. All right, next one up on our list is number 14. Number 14, dancers vary directly as band members. Dancers vary directly as band members. Okay, squared, band members squared, and inversely as conductors. All right, we do have to have a K up there for our constant. Now they're going to tell us what all these things represent in number form. Okay, there were 250 dancers. Okay, there were 10 band members. And we had 2 conductors. So we can simplify this down. We got 100K divided by 2, which would be 250 equals 50K. Okay, divided by 50. We're solving for K first. Okay. And let's see, that should be K equals 5. 250 divided by 50 is 5. So we got that. All right, so we know K equals 5. So we're going to come back. Let's see, we know we're going to have 5 here now for our K. Now we're going to change some things up. We want to know how many dancers there are going to be. If there are 3 band members, all right, so 3 squared times 5 divided by 15 conductors. So dancers, we've got 9 times 5, which is 45. 45 divided by 15. Dancers should equal, if I'm not wrong, 3. Dancers should equal 3 for number 14, and that is correct. Okay. All right, after 14 was 17. 17, determine whether the graph of each represents the graph of a function. If so, determine whether the graph is a one-to-one function or not. Well, here's the thing. A passes the vertical line test, so it is a function, but it does not pass the horizontal line test, because when you have something like this, okay, here's my vertical line test, here's my horizontal line test, okay? So if I had to put it this way, you know, I'm going to put it in this terms, no, or I'm sorry, yes passes the vertical line test, does not pass the horizontal line test. It is a function, but it is not one-to-one, okay? B gives you something like this, where we have some open circle, closed circle, open circle, closed circle, open circle, closed circle. And what you should find out with this is that it does, you know, it's going to pass the vertical line test in all these places. So it's yes, but if you'll notice, it's not going to pass a horizontal line test at any of those places. So my answer is still no for the one-to-one. Okay? All right, we'll pull this down. Let's see, we got a C in here. C shows me something that looks like this. All right, So it does not pass the vertical line test. So that's all I need to say. If it's not a function to begin with, then we don't care if it's one-to-one because it's not a function. So the answer is no, no at the very least. Okay, or just no. Okay, D. D gives me a circle. Okay, circle is not going to pass the vertical line test. So similarly, it is no, no. Okay, doesn't pass. If it doesn't pass the vertical line test, we don't care about the horizontal line test. All right, what was that? That was number 17, which finishes up our fives. We're going to go back to number 1. Number 1, draw the necessary reference triangle and evaluate 3 cosine 60 degrees minus 1/2 tangent 45 degrees plus 2 sine 30 degrees. And do not use a calculator, which should be fine. Okay, I've got a reference triangle. Let's see, we'll call that 30, 60, 90. This is 1, this is 2, this is radical 3, because I know my ratios. So what we wind up with is 3. Cosine is adjacent over hypotenuse. We're basing this on the 60, so adjacent to 60 is 1, and hypotenuse is 2. So I get 3/2. Didn't need a calculator for that. All right, next one, 45, 45, 90. Okay, we know we're going to get 1, 1, radical 2. So we want 1/2 times the opposite over adjacent, which is going to be 1 over 1. Doesn't matter which 45 you use, you're going to get 1 over 1. So you're going to get 1/2. And notice that I've got a minus there. So I'm going to subtract, okay, 1/2. All right, minus 1/2. And then we've got ourselves a 30, 60, 90. I could use the first one if I wanted to. Okay. Here we want sine, so we want to pick the 30 degree this time, and we want opposite. Opposite is 1 over hypotenuse is 2, and we want 2 times that. Well, 2 times 1/2 is 1, because my 2's are going to cancel out, leaving me with 1 over 1. Okay, and we want to add that plus 1. We could call that, because if I'm going to add all these up, I'm going to write that up as 2 over 2. All right, I got 3 minus 1 is 2. 2 plus 2 is 4. I get 4/2. So my answer is 2. Okay, you could use your calculator to check, but you better show me the work to get credit for it. Okay, that's the work that I want to see. All right. All right, after 1, you guys had number 4. Number 4. We want to evaluate 8 factorial over 4 factorial, 4 factorial. Well, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. So you can see these are all going to cancel out. And you can cancel out 4 and 2 and take care of the 8, because 4 times 2 is 8, leaving you with 7 times 6 times 5. Let's see. Without a calculator, of course, we know we're going to get this over 3. Let's see. 7 times 6, or you could do, I'll probably do 6 times 5. 6 times 5 is 30. And then you get 30 times 7. Of course, that's 0, and you get 21. So you got 210 divided by 3, right? Think of that as 21 divided by 3. 21 divided by 3 is 7, but we got a 0, so I should be getting 70, I believe, for number 4. That looks like that's right. So no need to use a calculator there. We know all that. Okay? You can use a calculator to check it, but you won't get credit if that's all you give me. Okay, number 12. Number 12 is a proof. Let's see, let me see what I want you to do on number 12. I'm going to answer this verbally because it's not going to matter a whole lot if I write this down, if it's going to be a little different on the test. But, so you want to write your statement. You're going to give your given. You should be showing that segment MN is congruent to segment O. And on the statement side, your reason is that a midpoint divides the segment into two congruent segments. Angle M is congruent to angle O, that's given. Angle M in L is congruent to angle O in P because vertical angles are congruent. We should know that inside, outside, forwards, and backwards. Angle L is congruent to angle P because two triangle are congruent to two angles in another triangle, then the third angles are congruent. You could write the third angle theorem. I would take that. There's probably a little bit of a way to get there a little bit quicker by using angle side angle. The way I would use it, but what they use here is angle, angle, angle side postulate. And then finally, we're going to use CPCTC to get there. So you could even do probably angle, angle side on this. So it's whatever works out. I'll try to look at it closely and give you the benefit of the doubt if what you have will work. So listen to the audio for the explanation. Okay. All right. Let's see, number 15. 15 I've already kind of showed on the board. You should get something. Let's see, 15. Oh, yeah. Okay. Nope, not what I was thinking. 15. 15. All right, so we've got 13x to the 5n plus 2 minus 26 x to the 3n plus 1. And we want to factor this. So what we're going to do is we're going to take our numbers. 13 is prime, so it's just 13. There's nothing else to do with it. It's just 13. But then I've got x to the 5n, so that's x to the n times x to the n times x to the n times x to the n. That's 4 times x to the n. Okay, that's 5. 1, 2, 3, 4, 5. X squared is just x times x. And then we get minus 26. Well, that's minus 2 times 13 times x to the 3n. So that's x to the n times x to the n times x to the n times x. So now what I'm going to do is I'm going to circle everything that shows up in both. So they both have a 13. All right, so I'm going to pull 13 out here. They both have 3 x to the n's. Okay, so I'm going to pull those out here. X to the 3n. They both have a single x. All right, so that's plus 1. What goes inside is what's left. So x to the 2n plus 1 minus 2. That's it. That's just, there's nothing else over there. So all of this comes in here and there. Okay, that's it. 13. I'm sorry, that's not 13, it's 15. It says skip, but I'll let you guys do it. Let me double check my answer on that. 13x, 3n plus 1, x to the 2n plus 1 minus 2 is our answer. All right. After 15 was 7. 7. All right, has multiple things here. Solve for x. Let's see, let's do a first. We've got log x2 equals 1/2. Okay, so I'm going to convert this to exponential form. That means the x is going to come up. The 1/2 is going to come as the exponent, and my exponent is going to become my whole number. Okay, so I got x to the 1/2 equals 2. Let's see. So x to the 1/2 is the square root of x to the first equals 2. So if I wanted to undo the square root of x and said the square root of x equals 2, I would square both sides. So I would get x equals 4. 7a 7a is 4. Okay, let's try to do b right here. b is log base 3 to the 1/3 equals x. We'll bring 3 up. We'll bring x there. X equals 1/3. Okay, so so the way that we want to look at this, 3 to the x, what I have here is 1 over 3, 3 to the first. And if I decided to move that up so that that 3 matched the 3 on the left, that would give me 3 to the x equals 3 to the negative first. And you can see by where these are positioned that x equals that number. X equals -1. Okay? So those can be a little tricky to see what to do with them. Let's see. And then finally, I think we have c. c gives me log base 2x equals -3. So 2 to the -3 equals x, and we're just solving here. That would be 1 over 2 to the 3rd equals x. Keep coming down. Okay. All right, that's going to be 1/8 equals x. And that's what we should get, x equals 1/8. Okay? All right, let's see, what do we have next? That was number 7. Moves us on to number 10. Number 10. Number 10, I think, is one that I did on the board. Now, if you plug this in your graphing calculator, you're going to go to that y equals part, and then you're going to hit 1 and divide by, and you need to do this next part in parentheses, x minus 2, close parentheses, in order to get this right. And your graph on number 10 should look a bit like this, where we would have an asymptote that comes across here, where these tick marks, right, this would be 2, okay, and then I'm going to show a table of values of x and y, and some of the values I could get are 4, 0.5, 3, 1, 1, -1, and why didn't we include 2? Because at 2, it's going to show an error. Okay, so you could show 2 with an error there, and then we'd have 0 and -0.5. Okay, so you should be able to give me about 4 to 6 points on a table in addition to the graph to show me that you got the right graph there. Okay, just be careful with plugging it in your calculator. Finally, we've got 2 more left, I think. We've got number 19. Okay, number 19 has 3 parts. Says we've got f of x equals 2 minus x. We've got g of x equals 3x squared. Okay, that's fine. A wants f times g of 3. Okay, so that means what they want us to do is we want to take 2 minus x times 3x squared, and you could do that, but the easier way to do this is going to go to just go ahead and do 2 minus, let's see what they want, 3, 2 minus 3, solve that, 3 times 3 squared, solve that, and then multiply. So 2 minus 3 is -1. Let's see, you should be getting 3 squared, which is 9 times 3 is 27. So I should get -27 for A. Okay? And then you could do B over here. Okay, that's the same thing, but we want to divide. Well, if it's the same thing, except with division, we've already solved for it with 3, so it'd be -1 over 27. Well, there's nothing really to change there. That's my answer. Okay? And then finally, C, they want f of g of 3. So they want me to take g, plug it in for the value of x, and then plug 3 in for the value of x in the g. So this is kind of a Russian nesting doll thing. So we're going to take f, and that is 2 minus, we don't need, I guess, that. let's 2 minus, and then we're going to take our g, 3 parentheses 3 squared close parentheses. That's f of g of 3. So that's 2 minus 27. That would give me negative 25. Let's see how right I was with number 19. It only has one listed, negative 1/27 for that. Well, we should have all three parts. Let me check the other answer key here. Negative 27 we got, negative 1/27, and negative 25. So we're right on all counts. All right. Finally, number 3 is our last one. Number 3. If f of x equals 4 sine x, okay, we want to find f of 330 degrees. Okay, we don't want to use a calculator, that's fine. Basically, we're saying we want to find 4 sine 330 degrees. Okay, well that's made easier. If I graph that around, we know that this is our initial sine. We're going to go all the way around until we get to somewhere in here, where we're 30 degrees shy of 360. Okay. We want 4 sine of 330. So we're going to use our reference angle here. We know that that's going to be negative 1 because we're located. We know we're going to be at radical 3 here in 2. So we want 4 times the sine of it. Well, 4 times the sine of this 30 degrees is opposite over hypotenuse. So 4 times negative 1/2 should be negative 2. Okay, if I double check. Number 3, negative 2 is my answer. And with that, I believe I've done every question that you guys had in order that you needed them. So I hope that this was helpful and that you guys do well on your test tomorrow.